Alright, streaming on Twitch. And streaming on YouTube also. Let's make sure the titles are 8. Yes, they are. Cool. Let's go to the chat, make sure I can see chat. Awesome. Alright, so I did a little bit off screen, not a ton, just like a couple of mediums just so that I could familiarize myself with them. But yeah, I think I did like 4 or 3 mediums, something like that. But yeah, they're definitely a lot harder. I'm not too familiar with how they work, so I'm very interested to see how this goes. Those who are joining now, basically this stream is about essentially learning how, or like kind of practicing for a meta interview, so to say. Like if we were to take one, we're just practicing for it. If you hear babies in the background, I'm sorry ahead of time, but yeah, there's babies in the background most likely. So we'll see how that goes. Let's make sure that I have chat updated. Awesome. So let's start with an easy and then we'll jump into mediums. Clear this out. We'll just do an easy and then jump into medium. Oh, binary trees, joy. Okay, so 270 closest binary tree or binary search tree value. This is a premium question. So given the root of a binary search tree, so the number 4, and a target value, return the value in the binary search tree that is closest to the target. If there are multiple answers, print the smallest. It's closest to the target. So let's get an example, please. So basically the root, so of this, the target is 3.714286. So the closest to that would be 4. So, man, I struggle with binary search trees. But from, if I'm breaking this apart correctly, the way we can go about this is, first of all, we search through each individual tree, go through each individual root, and check which one's the closest of the left and the right to the target. If it's null, then we ignore it. But we check which one's closest to the target by subtracting and getting the absolute value and seeing if it's less than the other side, basically. So let's go ahead and try that. So we'll have if root is equal to null, and we return -1, which will be our sign. No, that might not be a good idea. Instead, if root is null, I'm going to actually say private optional and integer find closest. We're going to pass in the tree node. Okay, so doing that, we can do as we please here. So if the root equals null, what is this doing? And return 0 essentially. Something's going on. It's going to do it now? Okay. I think my mouse was off the screen I'm recording. But now we're going to say if, we'll say if root.left is equal to null and root.right is equal to null, and we'll return root.value. It's not value, yep, it is. And so now we're going to say optional integer closest is equal to find the closest between the root and target. Then we'll say if closest dot is empty, which it shouldn't be, but we'll account for it anyway. We'll return 0. Otherwise, return closest dot get. We'll just go ahead and do that. Set that up in there. So this shouldn't have any issues whatsoever. Now we can get this out. So if node is equal to null, then we return optional dot empty. Then we're going to want to say if node dot left is not equal null, yeah, this is the part where I end up confusing myself. So we'll say int closest is equal to 0. Sure. Or we can say something like the node dot value is the closest, right? Because we know the node value is not null. So now we can say if it's not null, then what we can do is optional integer do recursion is equal to, and we can say node dot left, find closest for node dot left and target. And so now it keeps on going down there. If closest if val not is if val is not empty, then what we're going to do, say the closest is equal to the minimum between closest and not closest. Basic. How do I want to handle this? So that passes in there. If it's that, so we could say, so right now we're getting the value. So say it's 4. Well, now 4 is the closest to the target. Then we want to check if 2 is the closest to the target. So we need to say, okay, this is why I should not be left alone with binary search trees. It's actually, I'm going to get rid of this. We're going to say is root going to ever be null? The number of the nodes in the tree is 1 to 10 to the power 4, so it's never null. Okay, that's one check we can leave out. So we're going to say int closest is equal to, we'll say root.value. Then we'll say if root dot if, goodness gracious, this is confusing me so bad. If the left root is not null, then, or if the left branch is not null, then we're going to say temp here is equal to the closest value for root and target. Then if temp, the absolute value of temp minus the target is less than the math.absolute of closest minus target, and we'll say the closest is equal to the man, I chose quite an easy question, didn't I? It'll equal the 10, basically. Good. And then we'll do the same with the right root. So, oh, this isn't root, this is root.right. And then root.right, or root.left. And yeah, basically that all over again. And then we return the closest. I think this should work. Okay, it does work. Wow, I really confused myself with that one. Let's submit it and make sure that it runs all tests, and then I'll try to explain. Okay, 65 out of 66. I almost got it the first try. Ah, that sucks. Okay, so what are we doing here? 3.5. Okay. So, 3 is there. 4 is up here. So we return the closest. Oh, we have baby talking time, I guess. But if the left root is not null, then we find the closest value. So basically, I'm assuming this is returning 3 or 4. Oh, interesting. So what we're looking for then is return the value in the binary search tree that is closest to the target. If there are multiple answers, print the smallest. Okay, so we're going to in here say int, we'll just call it abs1. And then this would be a double one. Yeah, it's a double. So double abs1, double abs2, and then we have closest minus the target. So now I'm going to say abs1 is less than abs2. But then we're going to say, otherwise, if abs1 is equal to abs2, then what we need to do is say the closest is equal to the math minimum, not maximum, math minimum between the current closest and the temporary closest. Okay, that should work. Basically, everything's the same in there except for the root.left. You could make it into a function, but I won't. All right, let's see if this works. Yay, we passed, and we got 0 milliseconds. Let's go. So let me try to explain my thought process. Oh, I forgot to do a timer. Oopsie daisy. So my thought process here is we're getting the current closest, and then if there's a root on the left, then we're going to check the closest value of that left root. So the way that works is we're checking this value here, then we're going to check this value here because this one's on the left. And so the question is 2 closer to the target than 4? No, it's not. So then this absolute here does not trigger because we're checking the absolute value between temp minus the target and closest minus the target, and closest wins. However, if we do the same for the right side, so we would go to 5 then, and 5 is not closer to the target than 4 is. But if we keep going down, you'll see 3 here. 3 is tied with 4 for 3.5. And so one of the instructions is to make sure if there's multiple answers, print the smallest. And so 3 is smaller, and so I check if the answers are equal to each other. So if the distance between the two are equal to each other, then we're going to get the smallest between the two. Okay, so that's about it. And then we return whichever one's the closest. And this just continues to loop through no matter how many leaves you have. But this should be O of n speed. And in fact, we can click Analyze Complexity and big O n. Perfect. And I don't think we use any extra memory. I think this is O of 1. O of H. Oh, I haven't seen that one before. But yeah, so I think we did well with that. In fact, we beat the majority of people. I'm curious as to if I was... This person didn't know how to do it, so they just did return 4 for... Oh no, that's a different one entirely. Oh, never mind. I thought they just said if the target is 3.5, but it's 4.5. But that's cheesing it a little bit. So I don't know what to think of this person's solution. Yeah, let's try this one. See. Got tree node. I actually have not seen that data structure before. Interesting. I'll have to look that up later. But we've succeeded, and we've warmed up with a binary search tree. So I think we will be good to move on to some medium level difficulties. This might be a little bit more difficult. It will be a little bit more difficult. It's not even a question, really. But let's go to medium. Get rid of easy. Oh man, I don't even know how to deal with threesome. We'll go with letter combinations of a phone number and see what we get. So, number 17, letter combinations of a phone number. The topics here are hash table, string, and backtracking. I haven't heard of backtracking, but we can do hash table. That's fine. All right, so given a string, so since we're doing medium level difficulty, it's fine if we look through solutions in order to help us out and stuff like that. For the moment, or looking at discussions for hints or things along those lines, that's fine. I'm not going to crush myself with this. But let's go ahead and start the timer and see how we go. So, given a string containing digits from 2 to 9 inclusive, so I assume they're talking about the letters, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters, neither does star, or asterisk, pound, or 0. So if the digits is 23, then or if the digits are 2 and 3, then all the possible combinations. Oh, goodness gracious. I'm sure there's an n² solution here where you go through each and every single one where it's AD, AE, AF. Or digits of nothing equals that. So let's. Okay, so it can only ever be up to 4 digits. So let's go ahead and add some test cases where it is up to 4 digits. So 9876. And then let's do 3 digits, 364. Then let's also do, and there can be none, and there's already a test case for that. So let's do 5432. And one more, we'll do 9999. All nines. So let's get this figured out. So it's just a list of strings essentially, so that's easy enough to start out with. So here's my thought process, and let's see if I can get it into words. This is really important to do, especially for learning. If you want to learn, say your thought process out loud, try to explain it to somebody, see if they can understand, and things along those lines, and you know that you've properly learned the process. So what I'm going to be doing here is I'm going to make a hash table, essentially hash map of basically the number and the letters that are associated with that number. And so whenever a number is used, then all I need to do at that point is add the combinations of letters together. I think, yeah, so I don't see just A here. I see that you have to use the digits. If I press run right now and we say return output, let's see what this does exactly. Like, what are the expected responses? Okay, good. So it is as I anticipated, so that's great. So let's make a hash map. Is a hash good? What's the difference between a hash map and a hash set? Let's try a hash set. I'm curious. So we got a string and we got another string. That's all we got. Actually, we'll do a character. And then here we will say that it is the numbers equals a new hash set. Okay, so what is this one? Incorrect number of arguments. Okay, so a hash set is only 1. So we'll do a hash map then. I thought I'd try it out. We can try out a hash set for a set instead later if we'd like. So what we're going to do is all I'm going to say is numbers.put, and we're going to just do every single one. So 2 will have ABC, and then we got 3, 4, 5, 6, 7, 8. So 3, 4, 5, 6, 7, 8, 9. So number 3 has DEF. Then GHI, JKL, MNO, PQRS, TUV, WXYZ. So now that we have all of our numbers in, we should be able to just simply say for int I0, I is less than the digits dot length, I plus plus. What I could also do instead is just make a character array of characters, say digits dot to character array. Just I can't tell if it makes it faster or not. I should probably test that. If it does, that would be very helpful. So what we can do is say string letters is equal to the numbers dot get the characters of I. So now we have the letters we are supposed to display. All I'm going to do is say output.add. And I'm just going to say the letters. Okay, so it's at a maximum of 16 letters. Okay. It's going to be incorrect, but that's fine. I just want to make sure that everything's working as it should. We got one test case correct, yeah. Yeah, this is looking correct. Awesome. So we're getting what we want. Now comes the fun problem where we need to get all the different combinations. So we got the letters. And there's a talkative girl. Cut the letters. How do we cross multiply? Like, how would I even start with that? So we've got the letters. What we can do is loop through the letters, but then how do we get the next one? Yeah, this would become O of n squared if I did it that way, but let's just do it. So for int j is equal to 0, or is equal to I plus 1, sorry, and then j is less than the characters length, j plus plus, and so what you would do here, we'll just call this letters 1, and letters 2 is equal to numbers dot get characters of j. So now we have it, but see, the problem becomes that we would need more for loops, and I don't want to add more for loops because then it becomes a lot more complicated. Let's take a look at what the string has to offer. None of these in turn. That's interesting. What would you even go about doing? Because none of these are what I'm looking for. Basically, all I'm saying is now that you have everything that you need, you just say for int k equals 0, k is less than letters 1 dot length. Or you can even say char k in letters 1, and then for char j or l in letters 2. Does this want 2 character array? Yeah, it does. That's fine. And then you would just say, hey, how are you? Output dot add k plus L. That and not breaking the loop when you are done with the length. I mean, on right now, what I'm kind of doing is like the brute force-ish way. I'm trying to imagine in my head how this should go about. You're trying to add every character for that number, not break the loop when you're done with the length. What do you mean by that? See, I really don't like O and a n to the power 4. It's technically not really that, but it's pretty dang close. I have this, which is nice. If I want, say, 23, we want AD. Right. But if we... Gotcha. Backtracking is the way, I guess, when you are done with the character, pop it from the recursion stack. Interesting. Pop it, because then it's not used anymore. But it's a string. See, I was able to get the letters pretty quickly. You're saying to pop the letters, which in this case would be letters is equal to letters dot substring, where the beginning index is then 1. But then you don't really have a for loop anymore. Instead, you have a while loop while this is not empty. Oh, no, you do have a for loop. You do have a for loop. But then here you have a while loop inside of here, where while letters is not empty, basically. The baby's just screaming in the background. And so in here, got output.add letters, basically. Something like that. So then you got A, B, C, B, C, C, D, E, F, E, F, F. And so that way it pops. Let's see, how can I utilize that though? I'm trying to find a good pattern in there, but I'm having a hard time. W, X, Y, Z, X, Y, Z, Y, Z, Z, T, U, V, U, V, V. Like, what would you do with this, though? I don't know. Anyone have any ideas? I'm starting to run fresh out of them. Yeah, because this the topic is backtracking inside of here. We already got that hash table. We've got the string, but I feel like I'm just missing something. What is it that I'm missing? Could ask ChatGPT if I wanted to, but then it just pops out the answer. I don't like it when it does that. because I would like to learn. So, letters. Because, again, the problem is how to multiply the two together. The stopping condition should be length of string should be equal to the given string length, and then the inner loop should break and move to the next character. Even though I'm not sure, I'm trying with you. Well, thanks for trying with me. This is a very interesting thing. I'm not a huge fan of the one with pictures. I'm pretty not too good at the ones with pictures, but this one was pretty straightforward to understand what it wants. It's just kind of getting there with a good algorithm, so to say. If we want, we can take a look at some solutions. I'm not that dead against it, but it just feels like something I could figure out if I think a little harder. I mean, what if you just, because sometimes it just has to do with what it, sometimes having it in a new method and not looking at this nesty mess helps. So let's say combine, and then we'll say string left, string right. And so what we can do, because we need to combine them all. Because if we look at my case 7, there is a ton of different possibilities. I believe it's n factorial amount. No, not n factorial. Yeah, n factorial, because that would be 16 factorial, which would be a pretty large number. Yeah, that's a large number. Makes me think that this is not really possible to do with that, and we need to figure it out. I gotta ask this in an interview. Solve the problem of recursion on my own. Sometimes they give pretty decent hints, other times they give like the actual solution, and I don't like actual solutions, but LeetCode is trying its level best to teach me backtracking. Let's go ahead and ask ChatGPT what backtracking is. What is backtracking? Backtracking equals systematic trial and error with undoing. You're not going to be able to see my ChatGPT. Sorry about that, but I'll read it out loud. Build a solution step by step. If you reach a step where no valid choice exists, undo to the last decision point. I think I figured it out. Not sure it would make sense or not, but you need a recursion. Start recursion from index 0. Stopping condition is length equals n. That is length of given string, and keep adding the, oh, it cut out the last portion of your message unless if there's a limit to the message amount. But you need a recursion. Start recursion from index 0. So basically 0 to the amount of digits. Right? Add that string to array and then return. way main loop would keep running. Not sure. Not sure entire. I can give an example. Wait, okay. It sounds good to me. Oh, I ran out of time. Oh no, I failed. Problems include subsets, permutations, and combinations. This is a permutation, I believe. No, it's a combination. A combination. Gotcha. So, backtrack. You have a state. If the solution is found, then record the solution. At every intersection, you choose a path. If you hit a dead end, you walk backwards, backtrack to the last intersection, and try another way. Eventually, you either escape or confirm no way exists. So then, what? Let's see what GPT can also give me for an example. Is blank still considered a combination? That's funny. List of a list of integer subsets. Which this is a list of a list. It's basically a list of strings, which is a list of characters. DFS. So let's see if we can make sense of this. Let's say void backtrack where it's not an integer of numbers, it is string letters, index, list of string, path, a list, or no, just a string. Initial call find index equals 0. We're at index 0. The digit is 2. The possible letters are A, B, C. The function will loop through each of these letters. The A path. Choice 1. Pick A. Our current string is now A. Make recursive call to handle the next digit. Find 1. We're at index 1. The digit is 3. Possible letters are D, E, and F. This function will now loop through its own set choices. Choice 1, pick D, current string. Oh, pick D, current string becomes AD, best case. AD becomes 2 equals the length of the output. 23. Solution found. Add AD to the results list. Return from this choice. Backtrack. The current string goes from AD back to A. Oh, goodness gracious. Okay, I think I get what you're saying. How to put that into programming. Okay, let's see here. So basically the possible letters are A, B, and C. So we'll loop through each of these letters. The A path. Pick A. Oh boy, this is fun. Yeah, recursion. So basically, like these letters and for loop. Yeah, so this for loop is correct. We do want to get the letters there, which is good. We don't want that while loop. We got a weeping baby in the background. The path is not a list of integers, but just a string, I believe. String path. So we got letters, path, then a list of string result. I mean, just do a list of string here. And then, what did I just do? Then we this and put it here. It's equal to a new array list here, and then no, that's not what I wanted you to type. Return the result. Okay, so what we're going to say is if the current index is equal to the length of the letters, then we just simply return, not letters. We return the basically we can say result.add the path, and then we return the result. Like that. But under that, that means that we're not at the letter's length, and we can say path plus equals the letters dot character at the index. I see what you're saying there. Goodness gracious, this was do C +1 path, and then we can do result dot add. Not be add, it would be add range. Is that just C#? Add all. Okay. Add all, and then path is equal to path.substring. The length of the path -1. I think this is the begin, isn't it? Yeah, the begin index. So we need 0, comma, like -1. And then we say return result dot add all of the track letters index +1. You also need to return from the if condition. It does return here. What do you mean? Path. Boom. And we return the result. This is definitely easier with goodness gracious, this is complicated. Also, you need to loop on cars before the path plus equals, since we need all characters. You don't need to return, just return in case the condition. Well, I have to return something in case, since you just want to stop recursion. I mean, what it can just simply do, is list string result, and then I don't need to have any of this, and I can just say backtrack, and pass in the result here instead. Then at that point, the result will be handled for me. I can just say void here. Man. Yeah, I'm having a I'm just make it a void function, yeah. That you won't need to return, just add strings to a global result list. Yeah, precisely. I'll need to look into this more so that I can figure it out my own. But now it should be as simple. Result is equal to a new array list. Yeah. Now I need to figure out how to implement the thing. So backtrack would be the digits 0, the letters, and then result. I don't need result, I just need output. Just need to add a loop and it should be good. Great job. Second, let me run this really quick, see what I get. What an interesting result. I see what you mean now. So, what am I doing, by the way? I am a computer information systems grad. I already have a bunch of years of experience in. I have 7 years of experience in software engineering, but I do not often do data structures and algorithms. So I figured this would help me to learn and pursue and expand my knowledge. I do a lot of website programming, like we're talking about web dev software. Those forms. I do a lot of C#, but yeah. So I just need to loop through the for C. I do a lot of C#. So not putting in digits there. No, the company's not hiring right now. It's yeah, we're just we're looking for clients currently, but yeah, no, not hiring currently, no. So character C, letters dot to character array. Yeah, no problem. So we got we pass in the letters here. Why am I confusing myself so hard? Legit. What am I doing? So the pass in, or what would be the path to pass in? Would that be... Am I just confusing myself too hard? No, I'm not. That's far too many. Interested in kind of solutions there are. I'm just kind of screwing up at this very ending here. Pretty sure this is correct. Because it's doing what I'm telling it to. Then comes the question of this one with 4. Maybe do a dry run, you will figure it out. I just feel like I have to research a little more into this. I've never dealt with backtracking like this before, so I think I will continue on with this one, and I'll do it again on stream later and see if we can do it after I do some research on it. Because we spent a long time on this. A 4-sum. I haven't even done the 3-sum one. No. We'll do remove nth node from end of list. All right, we'll do this. I'll try the other one out again when I do some research on it, though. But let's reset timer, start it, see what we can do with this one. So we've got given the head of linked list, remove the nth node from the end of the list and return its head. Oh, that's interesting. Return head. Success! Wow! We did it. We returned the head. I believe, what are the topics for this one? 2 pointers, yes. I thought it would be that. So I believe this one's rather simple. So the goal is to remove 2 away from the end. I say simple, but I also haven't tried this before. This will be interesting. So 2 pointers works like this. So we have a list node called fast is equal to head, and a list node called slow also equal to head. What we can do is say while fast dot next, or no, what we do is say slow dot next is not equal null, and fast.next does not equal null, and fast.next does not equal null. So this would be 2 pointers, so slow would equal slow.next, and then fast is equal to fast.next.next. So I know I'm aware of this. I'm aware of this algorithm. It should, I believe it's O of n, and our goal is to remove 4. I believe what we need to do is essentially go forward n amount of times, and then when fast reaches the end, we remove slow from the list. I believe that's how it goes. So let's give it a shot. So 4 int I equals 0, I is less than n, I plus plus, and then we'll say slow is equal to slow.next, and fast is equal to fast.next. If I'm wrong, that's fine. We'll just figure it out. But essentially, when fast.next is null, or fast.next.next is null, then we'll say slow And wait. But how would I remove that? So here we just basically say slow dot value. Well, I guess what we can say is while slow dot next does not equal null, then we'll say slow dot value is equal to slow dot next dot value, and then we say slow dot next is equal to, or sorry, not slow dot next, slow is equal to slow dot next. Delete slow. We also need a previous, I guess, to delete slow. I don't think we need a previous, but unfortunately, they don't provide a previous. They never do. This is how list nodes work, unfortunately. I think that's how it goes, actually. Let's run it and see. Okay, next is equal to null. What? Wait, how is next null? Oh, because we also have to do slow does not equal null. And we also need to do fast does not equal null. Yeah, I mean, I would have loved to do that, but with list node, you don't have an actual length. Like it won't find the length, because they're nodes essentially. That's the reason why. All right. Slow does not equal null. In fact, we could just say if slow is equal to null. Oh, nah, we won't worry about that. That's right. See what we got. It did it. Hey, did it? It did do it. I think if we say if slow.next equals null, then we can just simply say like slow.next.val is equal to, or slow.next is equal to null. Something like that. No. Guess we can't do that. Oh, it died because I did it after I set. Oh, hey. This one worked. Why did this one not work? Because we're doing one. What was outputted? 1.2. Okay, I do have a gripe with these test cases. They're really annoying when they're small like this. We'll just say that. Then, oh, it can't be negative joy. Well, we'll just say that, and we'll say it needs to remove 5. This one needs to remove 3. This one needs to remove 9. And this one needs to remove 11. Let's run it, see what it does. Oh, these two worked. But this one did not. It removed a 5 instead. This one removed another 5. No. Yes. No. Wait, maybe. Why am I confusing myself? It's removing something. look. So 2, 3, 6, 0, 2, 5, 5, 5, 5, 5, 5. Okay, it's removing the 3. Okay. Not going insane. Good. So why does it not work then? Yeah, length of list minus +1. I am curious if Python would... Nope, unfortunately, Python would not allow you to do that. Nope, you have to figure it out without length. You gotta figure it out without all the other fun stuff. So slow.next. Slow is equal to slow.next. So this doesn't matter at that point, which is fine. I feel like I'm really close. It's 1. Would it be? Yeah, because that... Wait, but why... Oh, I'm so confused right now. Let's go ahead and debug here. Oops. I thought I pressed debug. Come on, man. Let's do a debug here, and we'll do a debug there. So let's give it a run. So n is 2, so this will run twice. What are the buttons for it? So now slow should equal 2, 3, 4, 5. That should equal... Yeah. So skip forward a couple. Then that goes down, and then it goes to 5. Then slow is equal to... is at 4. Okay, so something I could do would be up here, if the next slow is null, then just set slow equal to null. Something like that. If it's equal to null. And then just break. Let's take a look at this. 5, 5. Yeah, I thought that's what would happen. Unfortunately. If slow.next is equal to null, let's also then have a previous. We can say slow equals slow.next, which is fine. Then if slow is equal to null, let's set the previous next equal to null. Something along those lines. We got a big crying girl in the background. I really hope you guys can't hear them. Oh, this is so frustrating. I don't need the break here anymore. Then we can set the previous to the previous dot next. And the previous does not equal null. Come on, man. We'll also say and slow dot next. I don't really know what I'm doing wrong. Oh, goodness gracious. Let's take a look really quick. I think I might have done this wrong. I think I need to do this instead. Where goes fast. Then by the time it reaches the end, or is it the slow one? I think it's the slow one. Yeah, I'm pretty sure it's a slow one. So we check if that's all good. Then set the slow equal to the next. Like that. I don't know. Let's see how that goes. If slow dot next on next is equal to null, slow dot next is equal to null. I forgot to add that. Okay, so that's not finding it correctly, except for in case 5 apparently. Then let's try it with fast. 1, 3, 4, 5. 1 removes 2 instead of 1. 2, 3, 6, 0. 0's gone. What in tarnation is going on around here? I think I'd like confuse myself so hard right at the beginning. Keep the 2 pointers. Let's try it like this. Okay, interesting. Keep see, this is confusing me pretty bad. Probably gonna need to do some more research. I did a lot of research today too. Let's see if there's any good hints. Yeah, update 1 with a delay of n steps. It's exactly what I'm doing. Well, what am I doing wrong then? Try this test case before submitting. Okay. Like how that's the only one that succeeds. Got LeetCode expects the answer to be 1, but I understood that we have to remove the second element from end, which would be 1 in this case. My answer should be 2. Where is the test case guy? It's meaningless to use the 2 pointers technique. You won't get benefit from that. It still has the same dereference compare to 1 pointer to pass. You want to have cache benefit when n is small. I hope LeetCode can remove this misleading question. Okay. Let's try an entirely different approach with the 17 seconds we have left. So, what we can do is completely reverse it. We say while reverse. Oh wait, no, it's new list node. We put in the head.value. Then let's also make sure we got a temporary because we need to return the head. Can't forget that. So now we say temp does not equal null. Or temp, yeah. We'll say that. Then the reverse is equal to a new list node. And the value is going to be the temp.value. Basically check if temp.next exists. Temp is equal to temp.next. Temp.value. And then we can pass in reverse into here as the next. Cool. So now, why are you throwing an error? Wait, what? No, you told me right here it's available. Whatever. Well, then the problem becomes I need another list node. Temp2 is equal to reverse. And then you say reverse.next is equal to temp2. Whatever. Then all you gotta do is say for int I equals 1, I is less than n, I plus plus. Then all you gotta do, in fact, let's say int I equals 1 out here. And we can just say while I is less than n. And we can say what's interesting is that we do need to return the head. No, this also wouldn't work because we have to return the head, and reverse is a new list node. Oh, come on. Is it okay to ignore the memory leakage here? Oh, interesting.
My solution has one pass and uses an array list to capture all nodes. I mean, you could do that too. You could just, say list of integer data is equal to a new array list. And just simply while temp.next does not equal null, you say data.add temp.val. Then you say temp equals temp.next. I mean, you could just do that. Like, then you just say remove, I believe. Isn't there a remove at function? No, there isn't. Joy. But you can remove the one at n minus 1. Yeah, that's correct. Like, why? What is this? If I were to print that out, what would it even look like? Like, there's so many other ways to do this than with list notes. Let's click right here and debug it, I guess. Check it out. Data equals 2, 3, 4, 5. So if I, instead of doing n minus 1, we just do n. Oh, interesting. Okay. I need to do temp.val. No, not temp.val there. Data.add temp.val. There we go. Now let's try it. See what it does. Step over. And now 3 is gone. So if we just say -1, it should just simply do 4. That did 2. Oh, interesting. We can just do data dot size minus the n minus 1. Let's try that. Step over. I think it would be -2. Let's also move the breakpoint, please. Make it a little more bearable. Okay, fine. -n. One, two, three, 5. There we go. I mean, can't you just legitimately do this? No? Well, what if you go ahead and just 4 in I equals 1. I is less than data.size plus plus. Then you go ahead and you say head dot next. We'll also say and head dot next. It's not equal. I need to do more research. Well, maybe next stream we can just do a bunch of learning. Rather than diving straight into medium level difficulty, because this is definitely stretching my brain. Let's say head.next is equal to a new list node of data of I. What? What? Oh. Yeah, this is C sharp. Then head is equal to head dot or do it and not as fun. We say temp equals temp dot next, and you continue and then return head. Yeah. It almost got all the cases, which is not the first one. So let's do that. Interesting. All right. You know what? I'm going to end this stream here. I'm going to do a lot more research and maybe even do some research on stream, maybe with like ChatGPT or something. But I'm gonna go ahead and do that the next time I stream so that when we jump into it, we can just destroy these medium problems. Hopefully that sounds good to you guys because boy oh boy did this break my brain. I'm able to do easy no problem. Like easy problems are alright. But these medium ones are pretty difficult. And that's not even to talk about hard. Hard is is hard. So, all right. Well, I'll see you guys in the next one. We'll see what we can do about this. But yeah, I'll see you guys.